Okay, so now we're going to translate the absolute value function. So I have written up here in the dotted line the parent function. Now the parent function is the most basic type of that function. So as we break it down, as we remove all numbers on the outside, all numbers on the inside of the absolute value bars, the most basic function called the parent function is absolute value of x. And so we graphed absolute value of x. It's that V-shaped graph. Now we're going to maintain the V shape. It's just today we're going to move left, right, up, down. So sometimes it's called translations, transformations. We're going to actually do both between this video and the next video. All right, number one, what happens when we have a function or numbers on the outside of the absolute value? So if I'm adding 2, if you were to use your graphing calculator and plug that in, you would see that that plus 2 means that from my origin, every single point on this absolute value function is going to move up 2. So I'm going to go up 2, this point's going to go up 2, and this point's going to go up 2, this point's going to go up 2, this is going to go up 2. Every single point, it's like as if I'm lifting that parent function off the coordinate plane and I'm shifting the entire graph up 2. And this is what I would get. So you see every point, it's as if I'm lifting that off, I'm shifting it up 2 and placing it right back onto the graph. So blue here is line 1. Uh-oh, my dude, hang on little buddy, we're almost done. Okay, now what if you had a minus? What do you think minus would be if it's outside of the function? So vertical shifts happen outside of the function, so vertical up and down. If you're an athlete, think of testing your vertical jump, your vertical leap, how high you can jump. Number 2, what about minus 3? So if up or plus 2 means up to, minus 3 then would be taking this off the board, shifting it down 3. So as I shift every point down 3, we would have a graph like this. So again, it's as if I'm taking this parent function, starting back at the beginning, lifting it off the board, shifting it down 3, and placing it right back. Do you see how in one case we shift up 2, and then in the other case we're going down 3. And again, if you were using a graphing calculator to double check all of this, you would see all the coordinate points are shifting up and down. So now I know what you're thinking. You're like, yes, I got this. This is easy. Is that it? Yes, that is it. And you're like, yes, oh my gosh, I've never felt so secure in myself in my math career. And well, guess what? Let's take a look. Because you're like, okay, yes. Now, what about horizontal? Oh, left and right? Oh, that's going to be easy. Oh, okay, I got this, Reininger. Okay, all I got to do, oh, x minus 1. Boom, left 1. You're wrong. This is always opposite. When it's on the inside of the function, we have a horizontal shift. A lot of people may use the word high to memorize that. Horizontal is going to happen when we're on the inside of the function. So inside the absolute value bars, I'm going to go left and right, horizontal. Now, x minus 1 is opposite of what you would think, and it's because of the formula of the parent function. But x minus 1 actually means we go to the right one, and you're like, I can't do this. That doesn't make any sense. It takes a minute to get used to, but it won't be that bad. Just think opposite when it's on the inside. X minus 1, we're going to go to the right one, and if you're like, that just doesn't make sense. I don't understand how you even got that. Why am I even here? Why am I watching your video? You're watching your video because you have to and you love it. So, but use your graphing calculator to double check. On a test, if you forget if that's left or right, plug it in real fast. Plug it in and look from the parent. Oh, hey, that does go to the right one. Why does it do that? Oh, because it's opposite, right? Just keep trying to come up with memory devices to help you. And so, yes, it's like we're taking our parent function, we're lifting off the board, and we're going to go to the right. Now, what about this one, number 4? We're going to use purple here, and we're going to call this line 2. So number 4, it's x plus 4. So remember, it's the opposite of what you would think. So x plus 4 does not mean we go to the right 4. It actually means we go to the left 4. He is hanging on. I am so proud of you. So left 4. So 1, 2, 3, 4. So here's my point. And we know that the slope of absolute value, we're just going kind of up 1, right 1, up 1, right 1, all the way through. And then the opposite direction, because it's mirrored, it's reflecting about that vertex, right? This line of symmetry here. And so this would be our second line. So we're going left a distance of 4. Now you might say, okay, up and down, I got it. This means we're going up 2. Why? Because it's a vertical shift and it's on the outside of the function. So vertical shift is on the outside of the function. Horizontal shift, when it's inside the function, we're going to go left and right. So here's up 2, here's down 3. This is to the right 1, and this is to the left 4. Now, what about if we had some things combined? Let's take a look at that. What if we're combined here? Let's just do an example 5. So let's call this j of x. And what if we had the absolute value of x plus 1 plus 3? What would that be? Let's go ahead and check. So absolute value of x plus 1 plus 3. I know this is a bonus. You weren't even going to get this today, but man, I'm just feeling crazy. So let's go. X plus 1 plus 3. Let's use purple here for this graph. Now, easiest to think about is up and down first. So outside of the function, this is going to go up 3. So from my origin, I'm going to go up 3. Before I place my point, I need to see, is there a left and right? Remember, think opposite. This is x plus 1, so opposite. I'm going to go to the left 1. So I'm going to go up 3 and then left 1, and here is my new vertex. So this vertex went up 3 and left 1. Then from there, I would draw that general shape of absolute value going up 1, right 1, up 1, left 1. So this would be this new graph going up 3, left 1. So again, same V shape, but if I lifted this off the board and shifted it up 3, left 1, and placed it right back, it would land on top of this one. You do not have to draw the parent function as a dotted line if you do not want to. I think as you get used to it though, you should start this way. You should go ahead, every coordinate plane we give you, go ahead and just draw the parent function so you can pay attention to how it's shifting, how it's moving, and kind of remember that the slope of the parent function at least is 1. We're going to get next into where we're having numbers on the outside in front of the absolute value bars, and that's going to cause that V shape to open wider or to close.